Probability is the branch of mathematics that analyzes random experiments. A random experiment is one in which we cannot predict the precise outcome. For example, tossing a coin, rolling a dice, or predicting the winning number in a lottery. There are different kinds of probabilities. For example, the subjective probability. The subjective probability is a probability that is based on experiences or opinions about an event. For example, if you're thinking that you're going to be on time to your home, taking into account your experience with traffic. The other probability that we have is the experimental probability, which is based on the times that an event occurs, taking into account the number of times that you tried that event. For example, if we're going to throw a coin 3 times, and the first time we get a head, and the second time we get a head, and the last time we get a tail, so the probability to get a head is going to be 2/3. The formula for the experimental probability is also known as the relative frequency, which is the frequency of occurrence of the event over the number of trials in that experiment. So, in the example that we had before, when we had 3 coins and we get head, head, and tail, so n is going to be equal to 3 because we toss the coin 3 times. And the frequency of occurrence of our event, which was h, to get a head, so was 2. That's why the probability of getting head, the experimental probability of getting head was equal to 2/3. And the probability of getting tail is going to be equal to 1/3. That one was different from the theoretical probability because this one gives you a way to quantify probability that does not require carrying out a large number of trials. So, let's say for example that we're going to toss a coin. So the possible outcomes to toss a coin are going to be head and tail. So our sample space, which is the set of all possible outcomes of an experiment, always denoted by U, are going to be H and T. So the probability of getting a head is going to be equal to 1/2. Why? Because the probability of an event, A, is going to be the number of outcomes that make that event happen over the number of outcomes in the sample space. That's why in this case, because we have 2 possible outcomes in our sample space and only one of them is head, so our probability of getting head is going to be equal to 1/2. Now, we're going to find what is the difference between the theoretical probability and the experimental probability. To do that, we're going to take into account the formula for the theoretical probability, which says that the probability of an event is equal to the number of outcomes of that event over the total number of outcomes in the sample space. And for the experimental probability, the probability of an event is going to be equal to the frequency of that event in a fixed number of trials over the number of trials of that experiment, right? So the experiment that we're going to do right now is throw a dice. The first thing that we need to find for the theoretical probability is to know the sample space. So remember that the sample space is the set of all the possible outcomes in the experiment. So the possible outcomes that we have in this experiment are 1, 2, 3, 4, 5, and 6. Now, the event that we're going to take into account is A, which is going to be thrown an even number. Well, now, if we want to find what is the probability of that event thrown an even number, So we need to know which outcomes belong to that event, okay? So we need to find how many outcomes in our sample space belong to this event. So which outcomes are even? 2, 4, and 6. So in our event, we have 3 possible outcomes: 2, 4, and 6. So the probability of having A is going to be 3, because it's the number of outcomes that we have in A, over the number of outcomes that we have in total, which is 6. So we simplify this, and this one is going to be equal to 1/2, right? So now the experimental probability. To find the experimental probability, so because it's dependent on the number of trials that we repeat an experiment, so we're going to repeat the experiment 5 times and see what it happens, okay? So we're going to find the same event. Let's throw the dice the first time, and we get 3. Well, we're going to write that the first time that we roll our dice, our outcome was 3. And the probability of throwing an even number is going to be equal what? Well, how many even numbers do we throw in this experiment? Because this one is 3, well, is 0. Over how many times we try the experiment? Just 1. So our probability of having an even number is 0. Let's roll the dice again. Is 5. So the second time that we throw the dice, the outcome is 5. So the probability of having an even number is again 0, but this time is over 2 because we have tried the event twice. Let's roll the dice again. Our outcome is 5 again. So the third time that we throw the dice is 5. The probability of having an even number is 0 over 3. Again, because we throw the dice 3 times. One more time. Now the probability, well, in the fourth time that we roll the dice, we get a 2. So the probability of throwing an even number in this case is 1, right? Because we finally get one even number, over 4 because we have thrown the dice 4 times. Okay, so this one is equal to 0.25, right? So now the last time we get a 5. So the fifth time that we throw the dice, our outcome is 5, so the probability of having an even number is going to be equal 1 because we get 1 in the last one, but this time over 5. So, well, this one is equal to 0.2, right? So as we can see, the probability, the experimental probability and the theoretical probability are not the same. They are different, right? Here we have 1 over 5 and here we have 1/2, right? It was all, well, this is going to be 0.5, right? So we have that the theoretical probability is greater than the experimental probability. But this one is not going to happen all the time. Why? Because remember that when we're finding the experimental probability, we're going to take into account is the number of times, the number of trials that we're going to repeat the experiment. Okay, so this one is very important when we're finding the experimental probability. And well, I hope you understand this one is the difference between theoretical probability and theoretical. We take into account all the possible outcomes, and the experimental only the number of times that we repeat the experiment. See you next time.